EET 114, Chapter 23, notes continued. So, in the third section, the iron core transformer, we have EP, the effective RMS voltage across the primary winding in volts, equals 4.44 times the frequency in hertz, times the number of turns in the primary winding, times phi sub m, which is the flux lines passing through area A. um, ES is the effective RMS voltage across the secondary winding in volts, and that's the formula for that. Now, here's the big equation in this chapter. So if you take the ratio of the primary to secondary voltage, it's equal to the ratio of the primary and secondary turns. Likewise, if you do the phasor voltage line to ground, phasor voltage line to line, it's the same ratio. V sub G divided by VL equals NP divided by NS. Now, the current has a inverse ratio. I sub P divided by I sub S equals NS divided by NP. That's the phasor current through the primary is IP, and IS is the phasor current through the secondary, both in the amps. A is the transformer ratio, and it's expressed as x turns to 1 or x to 1 or 10 to 1. Example would be like 10 to 1. The reflected impedance and power, Z sub P equals A squared times ZL. ZL is the impedance of the load. ZP is the impedance of the primary circuit, both in ohms. So EP times IP equals ES times IS. So that's the power. So the power in the primary equals the power in the secondary. That's ideal. Power in equals power out. So you might be asking, what is the difference between line and ground? Okay, VG and VL. Line to line, going up here, line to line is when this is a line and this is a line. So the voltage line to line would be here to here, okay? Line to ground would be taking any line voltage and measuring to if one side is grounded. So from here, that's why it's called VG. It's voltage from here to ground. So that's what the difference is. We're not going to cover impedance matching.